This video is from my earlier course, back when I was building out these ideas. The fundamentals I cover here are still solid, but the frameworks have evolved significantly since then. Head to systemthinkinglab.ai to see how this turned into a full course series. Hello and welcome to my course. This course is named System Design Course for Junior Engineers. My name is Kea Shallow and I am a software engineering manager and a university lecturer. I've spent about 15 years doing software development, and in that course, I really have a great passion for junior engineers starting out their career and really wanting to come in and use this power that they got, which is called coding, to be able to build all the applications that we see and use every day. What I really have a passion for is I do believe that there are certain on-the-job things that you learn that I think can be taught more intentionally and really ramp up junior engineers more if structured in a more, for lack of a better word, academic way. And system design is one of them. So that is the purpose of this course, to really just take a different look at system design and actually focus on junior engineers and how they can understand it. So let's just get started. So first off, welcome to this unique course, focus on system design tailored for junior engineers. So the concept is that historically, system design, which I should describe as the end-to-end description of how a system works. Think about a blog website. You're thinking about the front end, the web page that you are interacting with. Then maybe that's interacting with maybe a server of some kind. And then perhaps there's data being saved in some location. Understanding how these components work together and understanding the end-to-end flow of how a system like that works, that would be like the beginnings of what a system design document or the system design of that application. So this concept of like, oh, I'm going to go and design, let's say, a large system is historically left to senior and more experienced engineers, which makes sense. You are building a new website, you're building a new application. You need somebody that can understand so many different areas, like how the front end will work, or how the website will work, or how servers should be configured, how data should be stored, what systems communicate with what other systems or APIs. This all makes sense. But the goal of this course is that you have, if you're a junior engineer, let's say less than 2-3 years of experience, you're just coming in to really to develop and to help out your team, build this application. The more you can understand the end-to-end flow, that can only be a benefit to your career and a benefit to your team and to benefit to the application that you're developing on. So the goal here is to demystify the concept of system design for junior engineers by breaking it down into well-understood building blocks connected to form cohesive systems. Because the truth is, a well-designed system is already broken down into understandable building blocks. The goal of this course is to demystify that, to show that these building blocks are not, even though they have complexities in them, depending on what you pick, they're not conceptually on a holistic level as complicated as it seems. It can be grasped early in your career. The goal of this course is to maybe see these building blocks in a little bit of a different way. So that's what that's the goal of this course and what we're trying to do here. So I'm going to go to the next slide. So what are these building blocks? So building blocks are the individual components that form a system, and each building block has a specific role in the system. Connecting building blocks creates a cohesive end-to-end system, so that when you connect one to the other, you start to see like, okay, this is actually like a larger system that works, that is end-to-end, but I also understand all the individual pieces that makes that happen. So just to give an example, I'm going to do some writing here. Let's say we're talking about a blog, right? A blog application. You go in, you're seeing like the top, 5 blogs and things of that nature. Let's just go through what some simple building blocks can be in a holistic, session. So first we go with, let me clear that real quick.
So like a blog, right? So you have this here, right? So first, you're gonna have, listen, I don't have the greatest drawing, so bear with me. Imagine this box is what we call the client, right? Or where the user or the person using the application actually interfaces with your application, right? So if we do that, then, imagine there's like people, drawing people here or a person looking at it. So you know that this is, the client most likely in this case will be a browser, right? So let me just say that right here, right? They're interfacing with your blog, your blog application. They're looking at posts and so on and so forth. So you know that there's some aspect that's data coming into your browser and showing the page, right? So next, okay, then what's showing the page? Okay, then maybe there'll probably be another box. We'll call that a server, right? And this interfaces with here. So the idea is that let's say you go to, myblog.com, right? And then myblog.com, so let's say I'm gonna write that here, myblog.com, right? And then it goes to the server and the server goes, chunks, does some stuff, right? And then brings back the information back to the client. And now you see your blog, right? So understood that we understand that we need something kind of waiting to like hear from the client to execute and then bring it back to the client. We understand that. But then it's like, okay, we have blog posts. And this is data that needs to be stored somewhere. So we can have some understanding that there's some place that has data, right? Let's call that a database that this will interact with. And so now you have a client, ask for a blog, it has the server going to the database, getting some data, putting it up in some way, sending it back to client so that a user can see it. This sounds really simple, but I'm telling you that most systems, actually I would say well-built systems, but should be able to be explained in this way. And this is what I want, like the goal of this course is that you as a junior engineer have the ability to go into whatever application you have and break it down into these building blocks, understand the properties of these different building blocks, and be able to understand a system as a whole as you're like, let's say, diving into the server and like building an individual block there. So that is what our goal is for this course. So let me clear that. Cool. So again, the holistic view of systems. The goal is to enable you, as a junior engineer, to look at the system end to end holistically. We're going to focus on how building blocks interact to form a cohesive whole. How did the server interact with the client? How did the database interact with the server? And then assess whether the system effectively fulfills the requirements of the system in practice. And the practice is important because, especially coming from, more theoretical backgrounds, let's say a computer science major, we're developing applications in the real world. So there's a number of considerations to think about whether, whether the system's up, what happens when the system is down, what components are better when lots of people, access the server at the same time. These things will be part of the holistic view of the system, which might not necessarily be a consideration if we're just looking to see how can we just make something work. So that's another part of this course. So, but beyond lines of code, I'm actually not going to, like, there's going to be no code in this course. It's not going to go into a particular language. The idea is that we're trading off deep focus for broader system understanding. Of course, as a junior engineer, the most important thing is that you know how to code, you learn how to code, go to all of the various resources to make sure that you have a solid understanding of how to translate thoughts into code. This course, though, the goal is that understanding, giving you this higher level of how a system works end to end, you can better use your coding abilities to know what to code in order to build the best systems. So the idea is to help you see the bigger picture of application functionality and essentially identify system-wide issues and optimization. So all of a sudden you can say like, ooh, there's an issue in the database. Let me go ahead and do something in order to make sure that it's running more efficiently in our real world system. So that's the trade-off we're making here. So back to the course objectives is to introduce a framework, a simple framework for system design centered around these building blocks to help you understand and build I can't speak today. Componentized, scalable, real-world systems using these building blocks, and to provide a theory, intuitive understanding the inner workings of these critical building blocks. And that last one is really important. Going to spend probably at least a whole section on this. That like it is easy to say, "Hey, I need a server," and you put up, you draw, you go in, you have it, and you draw your little box, and you say server, right? Boom. Yes. What does that mean? What is a server actually doing? What does this server consist of? And you might start having names of server and just start naming things like, oh, I need a Node.js server. I need an Nginx server. I need an Apache server. What does this mean? What is it actually doing intrinsically? And when you finally understand the things that are doing intrinsically, and this is where it goes into that senior level intuition, you start to find out that a lot of these different kinds or different types of servers are really doing the same thing in slightly different ways. And when you get to that base understanding, then you will be able to really understand how to make trade-offs between decisions, because you know what you actually need. And then you go and find out what's implementing that in the way that you want. So we're going to go into more of that in this next section, but just want to give a preview of that. Oops. Gotta remember to turn that off. All right, so why is this course needed? Just an overwhelming aware of complex technologies and tools. It's intimidating for junior engineers to keep up. And one thing that, again, I've personally experienced, traditional learning of this system design relies on the apprentice model. And what I'm gonna talk about the apprentice model is that the idea is you're a junior engineer, you code hopefully next to a senior engineer or staff engineer. You learn by coding and seeing how things are organized, and then you absorb it over time. While, there's nothing wrong with this. It's just not it's not the fastest way we can do this. And this is also saying that like we have no way of explaining system design. We just need to show it to you for a number of years and then you understand it. And I don't think, especially since, again, we've been coding for 50 plus years now. There's things we've learned already. Like, for instance, like if you think about other professions like medicine and so on and so forth, even though they highly, they have residency and they highly value this, like, learning by experience, they do have significant education that happens before that prepares them from that helps them learn some of the basics. They call it preclinical training. That's so that when they go into residency or go into clinical work in the middle of medical school, they're already like a step or two above. They're in a platform that they can learn even more and more rapidly because they've learned some of the theory and basics behind it. And I do believe that there's a theory of building system design in the real world. And that's what this course is all about. So this holistic view is typically not focused on in traditional paths of learning engineering, like computer science path, essentially is focusing more on the theory and making, understanding like data structures and algorithms, which is very important, critical. But understanding how a system works in the real world is just not part of the curriculum of typical computer science area. Coding bootcamp paths are focused on the practical, and they're actually a little bit a step above in this area. However, usually the holistic system design part is still usually not completely critical because the aim is to make sure that you can, get that entry-level job. And typically that entry-level job is focused on making sure you can develop, you can program in a couple, one or two languages efficiently. And the self-driven path is, it depends on how, the background of the person. But this is, again, it's like learning from what that person actually just runs into and learns on their own, which may be holistic, but typically it will start with, again, development and learning how to code, which is critical. But this is why there's a gap with system design understanding. This course's solution is to develop a simple framework for understanding systems and develop that senior level intuition without all the years of experience that we can just like with medical school, learn some things to get us to that next step, and then gain holistic and building block understanding early in your career. So the goal is to help you empower you to understand applications end to end, learn fundamental building blocks, their working strengths and weaknesses, and to build up that senior level engineering using gained through years of experience. So so I'm really excited to bring this course to you. And look forward to seeing you to the next video. Thanks.
This was from my original course on system design for junior engineers. Since then, I've refined and expanded everything you just saw into the full system thinking the AI era course, using these same building block principles across 15 plus real case studies. If this resonated with you, the link is in the description.